Okay, today's lesson would be on finance, grade 11. One part of the work is in the grade 10 lesson, so please go and recap the grade 10 lesson. Finance, grade 11. Now, finance is about growth and decay. There's a few words that we need to know. It's really important that we understand the terminology. The first one is compound interest. Compound interest is when interest is paid on both the original amount and the new interest every single month. So it's where the interest changes every month because it's based on the new principal amount every month. Now, simple interest is when the interest is only paid on the original sum of the amount. Hire purchase, like I explained in the grade 10 lesson, hire purchase is when somebody buys an item on credit, okay? And they use the item while it's being paid off, like a contract cell phone, or like a couch, or like a TV. You know, where you take contracts. Excuse me. That's what hire purchase is. Inflation is an increase in price over a period in time, like buying a loaf of bread in 2006 and buying one now. I don't think you guys were born in 2006, but anyway. Effective interest would be the interest rate that is actually earned per year when the interest is compounded more than once a year. Effective interest is very big in grade 11, so we need to learn that properly. There's other ones that's important, like present value and future value. That's more of grade 12, but we're going to work on what does interest that's compounded annually mean? It means it's compounded once a year. Semi-annually means every 6 months or even twice a year. Quarterly means every 3 months or 4 times a year, basically. And nominal interest is the interest that's stated, right? The interest stated does not take effects of the compounding. So it means the interest that they give you is not about all of the compounding amounts and all of that. But this is quite a simple question. It's quite simple definition. So you guys should not have any problems with that. Continuing, the ones that's important is the compound. So you and I are going to talk about compound interest. We're going to talk about effective interest and a few other questions. So let's start with compound interest. When it comes to compound interest, there's a few new parts this year that we need to talk about, right? So we spoke about annually. So everything you've been doing in grade 10 is annually, and annually means that it's 1 year. It's just once. So N, let's try and draw a table. I'm very bad with these tables. Okay. All right. So N is okay to deal with. N is just 1 and I is just 1. So we're going to go with N is 1 times N. So nothing changes. Okay, let's just leave it as nothing. Nothing changes. It's fine. Let's talk about semi. Now, the next one that we deal with is called semi-annually. When you see the word semi-annually, what it's talking about is twice. So now we're going to have N times 2 and I divided by 2. So we're going to take the number of years and multiply it by 2, and we're going to take the number and the interest and divide it by 2. The next one, I'm alternating colors, so it just works out. But the next one is compounded quarterly. Whenever you see the word quarterly, I mean, it goes quite well. Quarterly means 4. So quarterly means 4 times N and N divided by 4. Yeah, I divided by 4. Sorry, guys. I'm reading wrong today. Quarterly. After quarterly would be, remember quarterly is 4. After quarterly would be, let's go with monthly. I think monthly is fine. Monthly would be 12. So it means N times 12, I divided by 12. The next one would be very, 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 very rarely would be daily. or weekly, but you might see weekly a little bit more. Weekly is there's 52 weeks in a year. So N is times 52. I is divided by 52. And the most rare one that I've seen is daily, but it does come out in some questions. Daily is about 365. Right? This would be N times 365, and this would be I divided by 365. And that's all there is to the new part of grade 11 for now, for basic calculations. We'll be practicing some examples taken from worksheets, taken from government textbooks as well. And let's put this one here. There's some practice examples for you guys to use. I'm going to do a few. I'm going to do a few of them. Let's go with A. Okay, so I'll deal with A. I'll deal with C. I'll deal with, yeah, okay, A and C is fine. The rest you guys can work out. We'll deal with it in a few questions with timelines next. But I'm sure this one works out. Okay, so we're going to deal with A and C. Let's start with question A. For question A, we know all of the information. It's not like it's very difficult, but it also does take a bit of effort, right? So question A starts with saying, let's go start by labeling A, P, I, N. A's value is 6,080. Oh, P's value is 6,080. P's value is 6,080. A's value is unknown. I is 7.6%. And N. So let's go with 7.7% compounded semi-annually. 7.7%. And N is 3 years. Now, guys, it takes a bit of time. I'm scrolling up and down, but it's quite simple to deal with, to be honest, because now once you have the question in front of you, which isn't that difficult, but once you have the question in front of you, it's quite simple to deal with. Now, they said semi-annually, if I'm not mistaken. Semi-annually means I is divided by 2, and N would be times by 2. Okay? So again, what would happen now is 7.7 divided by 2 is 3.85%. That's 3.85%. 3 times 2 is 6. So this is easy to deal with. You all know that I prefer decimals, so this will be 0.0385. Let's work with it going forward. Okay, so very simply, A equals to P. 1 plus I to the power of N. A equals to 6080. 1 plus 0.0385 to the power of 6. And if we solve this, we should end up with 6080 times, open bracket, 1 plus 0.0385 to the power of 6. And that's 7,000 some change. Okay, 7,000 some change. 7,626.80. Now I just used the values from here just to calculate, because I wanted to work on the calculation itself. But remember that this is if the price is increasing. This is what it would be. In the proper question, this is depreciation. So this is example 1. Let's go and do example 2. So example 2 is the exact same question, but now it's depreciation. This is what the question wanted us to calculate. Depreciation. And let's start working. This is A equals to unknown, P equals to 60, 80, I equals to 7.7 divided by 2, and N equals to 3 times 2. This would be 0,0385, exact same thing. And this is 6. Let's go with A equals to P. 1 minus I to the power of N, and it's the exact same amounts, 60, 80. 1 minus 0,0385, and that's a 6. And this final answer should be 4,803 Rand and 96 cents. So this is the depreciation. Now, let's go with question C. We're going to do question C as depreciation because that's what the question wanted, but it is the same thing, the plus and minus. You just need to know when to use each one. We'll start off with A, which is 6330. P, which is unknown. I, which is 3.4% divided by 365, which should give you 182500, right? Because it's daily. And N, which is 4 times 365. Now 4 times 365, if I'm not mistaken, 4 times 365 should be 1460. Okay. Please double check all answers in case of algebra mistakes. And let's work with this. So P's answer is unknown. This is 6330. This is 1 minus, and this answer is 17 over 18 to 500. And this is to the power of 1460. Right? If we simplify this, this is 1 minus 17, 182,500 to the power of 1460. We should get an answer of P into 0,87283, some change. I'm not writing the whole answer down. P is 6330. I prefer this because I can see mistakes. This bracket over, it's taken over as division, and P is equal to 6330 divided by this amount, and I get 725. 2.21. I think that's a better number to deal with, and that would be quite simple to deal with. The rest of this can be done as homework. I'll find some time to make another video to complete this. Okay, this video falls under part 1. So we're going to do a little bit of timelines, just to touch on timelines. But timelines are quite simple to deal with, and effective interest. There'll be a part 2 with more questions. I think you guys need a little bit more questions, and part 3 would be exam papers. Okay, so when it comes to timelines, this person invests 5,000 Rand, 5,400 actually, into an account paying 14% compounded semi-annually for 2.5 years. So let's start off with calculation 1. That's 5,400 gone for 2.5 years, and it's paying an interest of 14% compounded annually. Okay. The next calculation, this person also withdraws 3,000 Rand. Let's stop. Okay. No, it's fine. This person withdraws 3,000 Rand minus 3,000 Rand and invests the rest of the money into account paying 7% interest compounded daily for 3 years. So this is another 3 years. They're paying 7% compounded daily. We'll have to take it step by step so we don't make mistakes. This person then changes his investment to account paying a certain amount monthly. So we don't know what the amount is. We know the interest is there, and that's over 12. We don't know what it is. And after 4 years, that means 4 years later, he has amount of 9,096 rand 0.92. What is the value of X? Okay. So this entire timeline is about us working forward to finding out the interest. Now, any way that this stands, there is 1. There is, I don't want to put too much color on this page, but there is 2. And there is 3 calculations, right? If you're not counting the minusing of the money, but there is 3 calculations. So this can be done quite easily. Let's start with calculation 1. For calculation 1, we go A, P, I, N, A, P, I, N. A is unknown, of course. P is 5,400. I is 14% divided by 2. So 14% divided by 2, which should be 0.07, if I'm not mistaken, right? Because that's 7%. And this is 3,000. My pen's not working properly. And N is 2.5 years times 2, which should equal to 5. Now, if we do the calculation, this is A equals to P. It's an investment. So we know the money is increasing. This is 5,400 into 1 plus 0.07. And this is to the power of 5. And this guy, at the end of 2.5 years, has 7,573.78. This thing. Now, rounding off here, we'll call it a small error, like a really, really tiny error, but I mean, it's okay. It's manageable for now, just to learn the timelines. So 7,773.78. So what happens is here, 7,773 or 700. Yeah, sorry guys, my numbers are not working here. 7,573.78. Okay, cool. Now, calculation 2, we need to remember that this guy withdrew 3,000 rand from his account. So we also need to minus out 3,000 rand. And when we take out the 3,000, we get 4,000 some change. And now that's okay to deal with. Okay. So it means starting off at 2.5 years, I'm taking out all of this color. Starting off at 2.5 years, he had 4,573.75. Now the next calculation is quite simple. Let's change the color to red. A, P, I, N. The A value we don't know. The P value is 4,573.75. The I value is a little bit iffy, but it's 365. We can deal with that. That's 7% divided by 365. And that equals to 0 commas. Let's just use the fraction. I think it's easier. It's too many significant. 7/36,500. 7/36,500. And N would be 3 years times 365. So N is 3 times 365. 3 times 365 is 1095. Okay. Now, if we solve this, a equals to p, 1 plus I to the power of n. P equals to 4, 5, 73.75 into 1 plus, let's move this closer. I ran out of space, guys. It was calculated. 7 over 36,500. And then that's 1095. This answer should equal to, let me double check. That's 4573.73 or 75 in general. I don't know why it went to 5. This should have been 8, but I just minused out quite simply. My decimals are not working today. I think it's a little bit too much of math. Times 1 plus 7365 there, the power of 1095. Okay, so I get 5, 6, 42.46, right? Always double check all answers. Mistakes in timelines are going to be a really big problem because each answer carries on to the next part. So it means after 3 years, this guy has an amount of, let's bring this, an amount of 5,642.46. It's quite simple to deal with because we don't know much, but it's enough because we know A is 9,096.92. We know N is 4 years times 12, which is 48. We know P is 5642.46. And we don't know I, but we do know that I is divided by 12. Okay, so if I is divided by 12, the rest of it should be okay. Because A equals to P, 1 plus I to the power of n. A is 1996.92 equals to P is 5642.46. Move it there. We know that this is 1 plus. Let's just leave it as I over 12. And this is to the power of 48. To solve this should not be a major problem. I think it is quite simple. As long as you don't mess up any of the decimals. I am going to take it over one time because it's less messy for me. I'm going to take the 48 over as well. So this should be 1 plus I over 12. I just think that gives me a little bit leeway to deal with the decimals. This will be 1996.92 divided by that answer, and I'm going to root it by 48. Okay, so we got a weird answer, but I got 1.01 and a whole lot of zeros, and that equals to 1 plus I over 12. If I take plus 1 over, it becomes minus 1. So this becomes 0,011 continuing, and that equals to I over 12. Now this, again, I am running out of space again, so let's try and take some space somewhere. This is simple to deal with. If we take the 12 over, the 12 becomes multiplication times 12. And I end up with 0,12 equals to I. And please remember that interest is always times 100. 12% equals to I on the dot. And that should be the first timeline. This would be part 1 of the lesson. We'll deal with part 2, as in part 2 would be effective interest, and maybe 3 more timeline questions. 3 timeline questions should be good. Okay, good luck, guys.